Hello beautiful people. Today we are in 9.7, which is all about linear, quadratic, and exponential models. Our SWAB Act is to classify data as linear, quadratic, or exponential. A little bit of a review. Linear is typically of the form, slope-intercept form is y equals mx plus b. Your standard form for that is ax plus by equals c. And then linear, obviously, when you graph it, you're going to get a line. Quadratic, which is what we've studied in this unit, the standard form is y equals ax squared plus bx plus c, and that's going to have a U-shaped graph, either like this, or it might open down instead. And then we also had exponentials, which is of the form y equals a times b to the x. That's where your variable is an exponent. That's where your variable is an exponent. So the degree would be 1, x squared will be quadratic, and then exponential, your x is your exponent. And then remember, this would be exponential growth. It could also look like this if it's exponential decay. And then if it's neither, it might look like that. But these are your general forms. So today we're going to classify some data as either linear, quadratic, or exponential. So the first thing that we need to do is to graph each set of points, and then we're going to determine which one it fits. So looking at all of these points right here, I see that I have to go all the way up to 11 for the y's, and I have 1, 2, 3, 4, 5, 6 lines. So for this equation, I'm going to have to go by 2's instead. I'm going to go by 2, so each line is 2. So for 0, it's going to go 2, 4, 6, 8, 10, 11. For 1, 2, 4, 5, 2, 2, 3. So graph each of these. You don't have to really wait for me. This is 3, 2, 4, 5. And then we have 4, 2, 4, 6, 8, 10, 11. So I'm looking at that, and what does it look like to you? Hopefully it looks like the same thing that it looks like to me, which would be quadratic. If you could take one moment right now and plot the points for B and for C on these graphs, and then determine if they are quadratic, linear, or exponential. Please press pause now and do that. Okay, and so for part B, you have these points plotted, this data represented here, and if you're looking at the data points, they all connect in a line, so I would say that this would be linear. And then here we are at part C. I still continue to go by 2's just because of the data points. When you're drawing your own graphs, you could do them however you'd like to, so that you don't have this problem. But for these, I'm looking at them, and they seem to be decreasing rather rapidly. So this is exponential. This would actually be a case of exponential decay. All right, well, that is how to differentiate between linear, quadratic, and exponential. To get a little review section, and more on the next lesson. Thank you.